this video, we're going to look at graphs of common functions. These are functions that you're going to see throughout the Algebra 2 course, so it's going to be easiest if you memorize some basic functions now or recognize them. So the objective is for you to be able to recognize graphs of common functions that you'll see throughout the course. First one, this is a review from Algebra 1, and it is f of x is equal to x. Now notice we've already done f of x notation, so I'm making my dependent axis what you recognize as the y-axis probably, but this is actually the dependent axis, and I'm labeling that f of x. Now my independent axis is x, and I chose the variable x because you guys are used to it, but it could have been t or s. This is my independent axis. So I'm graphing f of x is equal to x. Well, this is a linear line, so that means that it is at a 45-degree angle, and it just splits the first quadrant, and it does that with the third quadrant as well. So there is f of x is equal to x. Now let's look at f of x is equal to the absolute value of x. Well, if you notice, the absolute value here, it doesn't change the graph in the first quadrant. That's still the same. However, what the absolute value means is that for whatever input I put in here, my output is always positive. So therefore, if I put in a negative 1 for my x, my output is a positive 1. If I put in a negative 2, my output is a positive 2. So that changes my graph, and I get this graph, which resembles a V. So remember, f of x is equal to the absolute value of x. I get this V-shaped graph. Okay, with f of x is equal to x squared, well, if I plug in a 0 here, I get 0. If I plug in a 1, I get 1. If I plug in a 2, I get 4 now. Because when I plug in a 2, 2 squared is 4. So 1, 2, 3, 4. And that gives me, in the positive quadrant, I have this shape. Now, if I make these negative for my negative quadrant, when f of x is negative 1, or when x is negative 1, sorry, my f of x is still positive, because when you square that, you still get a positive number. And when it's negative 2, comes up here. So you can see the symmetry in this, and we'll learn all about this in quadratics. But this is symmetrical. So I get this U-shaped function. So there's my u. So f of x is equal to x squared gives me this U-shaped function. And it's actually not a u, it's called a parabola. You should remember that back from Algebra 1. The sides never go straight, so this is called a parabola. Okay, let's look at the next function. F of x is equal to x cubed. Well, let's look at my parabola, and let's just change it a bit. So if we have f of x is equal to x cubed now, notice that when I had a square, my dependent variable can never be negative, so that's why it's in this quadrant, the second quadrant. But now for x cubed, it's not the same. If I have my x and my f of x, we again have 0, 0. But now when my x is negative 1, my f of x is negative 1. So that puts me down in this quadrant here. And when my x is 1, my f of x is 1. So it might look like this would be a linear line, but we'll see when we hit 2 that it is definitely not a linear line. Let me move this a bit. So when my x is 2, if I plug that in, I would get 2 times 2 times 2, which is 8. And when it's negative 2, I get negative 8. So let's look at this. When it's 2, I get 1, 2, 3, 4, 5, 6, 7, 8, somewhere way high. So estimate a point right there. And negative 2, it's super low at negative 8. So I'll estimate that point. And let's fill in this graph to show you guys what it looks like. Okay, so this kind of has a double curve, or almost an S shape, you could say. Alright, let's look at the next one. F of x is equal to 1 over x. Now on this one, I'm just going to draw the function, and we can see that as x gets bigger, we're going to get smaller and smaller. We're going to get closer to the 0 axis. So the function looks like this. Let me redo this. Let's put in a spot when x is 1, we know it's going to be, my f of x is going to be 1. So we can approximate the graph like this, where this is actually a curve. Fix that a bit. And it's getting closer and closer to these axes, but it's never touching. Now, if I look at this, the same thing is happening in the negative quadrant. When my x is negative, my f of x is going to be negative 2. So let's clone this, and let's flip it. And that actually goes right here. So you can see this is f of x is equal to 1 over x. This is an inverse relationship. Last one we're going to do is f of x is equal to the square root of x. And we'll see that if we did the table again, well, we still have 0, 0. And let's do when x is 1, if I plug 1 in here, f of x is going to be 1. And let's do an even square. So if I put x is 4 here, my f of x is going to be 2. And that gives me this general shape. When 1, 2, 3, 4, it's 2. And I can approximate the curve here and say that my function looks like this. Alright, now if we look at this, this is a curve, and we can see that my x cannot be negative here. It's not possible to have a negative underneath the square root and get a real number. So this doesn't work. Okay, this is the common graphs that you guys need to recognize. And we'll be going over the domain and range of these graphs in the next video.